in Time. Tonight featuring Coast to Coast AM from August 21st, 1996.
From the high desert and the great American Southwest, I bid you all good evening, good morning, as the case may be, and welcome to another edition of Who Knows What. That's live talk radio all night long. From the Tahitian and Hawaiian Islands in the west, east to the Caribbean and the U.S. Virgin Islands, south into South America, north to the pole, and worldwide on the internet, this is Coast to Coast AM. I'm Art Bell. Great to be here again this morning. Great to be back in general. And we've got what's going to be a very interesting program this evening, because I've got a lot of questions, and I'm sure you do too. You all know that while I was gone on vacation, as occurs when I'm gone on vacation, because that's the way it is, I have no other answer, big things break. NASA suddenly announced that, lo and behold, they have a meteorite recovered, which they thought contained life. Fossilized samples of life from the planet Mars. And that was followed up, or on the heels of that, we got other news about Europa and the possibility of a watery center to Europa, and that there might be life there too. Non-trivial revelations indeed. And I have many questions, and I'm sure you do, and we've got a man this morning who may be able to answer some of them, Dr. Harold Levison. He is a senior research fellow, Department of Space Sciences, Instrumentation and Space Research Division, and works for the Southwest Research Institute. His MA in Physics, Franklin and Marshall College in 81, MS in Astronomy, University of Michigan, 83, and a PhD in Astronomy, University of Michigan, 1986. His principal research interest lies in the area of the dynamics of astronomical objects. In particular, he focuses on the long-term behavior of the solar system and its bodies, though he has undertaken both observational and theoretical projects in pursuit of these interests. Most of his research involves the development of large-scale numerical experiments. So, if he researches the dynamics of astronomical bodies and objects, he'd be a perfect person to ask how a meteorite gets from there, Mars, to here, the third rock from the sun. His work on the solar system includes studies of the long-term dynamic behavior of comets, the dynamics of objects in the Kuiper Belt, I believe it is, the stability of Trojan asteroids, and the origins of Pluto. He has recently performed a numerical integration of the orbits of thousands of the belt objects for the entire age of the solar system, about 4 billion years. In addition, he has performed the largest CCD search to date for slow-moving objects in our solar system. He is also a member of the team that used the Hubble Space Telescope to find objects the size of Halley's Comet in the belt 4 billion miles from the sun. And he has a professional chronology as long as your arm. He's a member of the American Astronomical Society, Division of Planetary Science, and Division of Dynamic Astronomy. So we have a heavyweight on our hands here. And in a moment, we will ask him about all the recent revelations.
Now we take you back to the night of August 21st, 1996, on our spell, Somewhere in Time.
It also, by the way, is fortunate we have the doctor here this morning, because the following just cleared the
on Art Bell, Somewhere in Time.
It also, by the way, is fortunate we have the doctor here this morning because the following just cleared the wire. Scientists later this year will head back to the Antarctic, the ice fields, where the famed Martian meteorite was found, in the hopes of finding up to 1,000 more. Ralph Harvey, who will lead the search funded by the National Science Foundation, has disputed NASA's claim that the meteorite known as ALH 84001 indicated possible Martian life. But he says more study of the rock and others is needed. He says it's just a coincidence that his team is going back to the same area where the famed meteorite was found. He says the trip was planned a long time ago. Almost sounds like an announcement from the White House. Every time they get ready to do something, well, we have this scheduled for the last year and a half. At any rate, let's go to Colorado, I think Boulder, Colorado. And here is Dr. Harold F. Levison. Dr. Levison, are you there?
Good morning.
Well, good morning. First of all, thank you for coming on the program.
Well, it's my pleasure.
I was out of the country in Europe and Scandinavia when all of this news broke. Never fails, I go on vacation, something big happens. And so the big news that broke that I got on the ship, here I was in the middle of the ocean, and suddenly the lead story is life on Mars. So I'm hardly know where to start, except do you recall the essence of the news release, the way it first was released?
Yes, I actually came home the day of the news the press conference and spent 2 hours sitting in front of my TV watching the press conference, trying to understand exactly what these guys were claiming. The actual article didn't come out until this week. I actually only read it this morning.
I see. So it was a 2-hour press conference. Did you sit there watching all that with your jaw hanging open? Were you surprised?
I was surprised. I also had a great deal of skepticism, and I still do. As a matter of fact, I think the scientists involved also are skeptical. I don't think anybody's really claiming that they found proof that life wants to go to Mars. What they're saying is there's a line of evidence, 4 different points in their argument, actually, which leads them to conclude that the simplest explanation, called the simple, is that life on Mars created what we see.
All right, let's try it from this point of view. If you had been the lead scientist, team leader, who was looking into all of this, with the evidence they had, would you have gone public at that time?
I think so. They were very clever in what they did, and they were also very careful. They wrote a paper, and they submitted it to one of the leading scientific publications in the world, Science Magazine. They had it refereed by their peers. They got comments back, and it wasn't until the paper was actually accepted for publication that they held the news conference. I think that's sort of rare in science. When a big news breaks, the people that usually hear about it first are the media.
Sure.
In this case, they were very, very careful. They didn't tell the media until after they had the paper accepted for publication.
So they had peer review.
That's right.
All right.
Now, I must point out that's only 2 referees in the whole world. The rest of the community, I think, is fairly skeptical, although it's fighting.
All right. Had you been a referee, I take it you would have agreed to go ahead and go public.
Maybe. You have to realize that the lines of evidence that they use come from very different fields in the astronomical community. The astronomical community is not this big monolith type thing where all astronomers have the same expertise in various areas. This particular work required people who were experts on fossils on Earth, geologists, something about atmospheric science. All that needed to be wrapped together in order to produce what they produced. I'm an astronomer, so I only know something about one area the solar piece of work. And as you said, that's the actual dynamic, or the orbital evolution of the rock once it left Mars to the point where it gets Earth.
All right, well, we'll get to that in a second. When was this found, this meteorite?
I believe it was found in 1984.
84. So, in other words, 12 years ago.
That's right.
That's a long time. Any idea why they just now are concluding that G is from Mars, and G, it shows that there was life there perhaps millions or billions of years ago, whatever?
Well, really, what happened is a lot of pieces of evidence came together. The idea that this particular rock from Mars was actually quite old. People have understood that about this particular rock for many, many years. This research team, the other aspect of this problem is that it's a technological breakthrough that allowed them to actually measure what they were trying to measure.
All right, what is the scientific basis for concluding that it came from Mars?
It has to do with the chemical makeup of the rock. Each planet we have found, that we visited, has its own unique fingerprint, chemical fingerprint. And when you study this rock and the other rocks like it, this is not the only known Martian meteorite. All right, they all have a signature that's identical to Mars, and it's not consistent with it coming from Earth.
That's distinctive. It is so distinctively different from something that would be from Earth.
That's right.
Okay. How many samples do we have that from different planets? Do we have just Mars, or do we have Mars and I know we've been to the moon, or do we have to have physical samples to get these signatures, or can it be done with satellites? Or
well, we have to go and actually sniff the atmosphere and dig into the rock. So the only places we really have this information for are the Earth, the Moon, and Mars.
And Mars, right. The next obvious question is how something gets from Mars to the Earth. I talked to a scientist the other day, and obviously it has to be blasted from the surface of Mars, which means there must be some sort of impact on Mars.
That's right. And this rock shows evidence of having such an impact.
Oh, it does?
Yes, there are fragments to it that indicate that it was probably involved in an impact.
Okay. The scientist I talked to the other day, and you can confirm or take issue with this, said, I said, look, wouldn't it have to be something along the lines of the KT event, that which wiped out the dinosaurs here on Earth? And he said, no, more like MT. Would you take issue? In other words, a gigantic explosion of some sort?
Absolutely. Well, the KT event is an impact that occurred 26 million years ago that pretty much changed the atmospheric dynamics of the Earth, made it a lot colder. And believe that was the extinction of the dinosaurs. This impact would have to probably be a lot larger.
Did the KT event that occurred on Earth throw things out of Earth orbit or even into Earth orbit? Would it have done that, or simply been something that screwed up the atmosphere?
It turns out that our studies show that it's a lot easier to get stuff from Mars to the Earth than it is to get things from the Earth to Mars.
Lesser gravity, or
less gravity, and also thicker atmosphere. So, it's interesting. One of the questions I had when I saw all this stuff was that the light that they seem to be finding on Mars, what they're doing, is very similar to the light that we find on Earth. That's how they're making all their arguments. I thought that was a little odd. But I thought about it a little bit, and it could be that what we're seeing is not independent light. That maybe Mars and Earth were swapping fifths, as a friend of mine put it, over the entire history of life was forming. And it could be that these two instances of finding life, if indeed Mars does have life, is not an independent occurrence. If that's the case, and this is all really idle speculation. If that's the case, our study shows that it's a lot easier to get stuff from Mars to the Earth than the other way around, and maybe the place that life actually formed was on Mars. and we're all Martians. That's an interesting
It is.
speculation.
It is indeed, and it validates the research of a lot of people like Graham Hancock and others. Or are you talking about a microbial
Oh, I'm talking about entirely the microbial
level?
right? I mean, the way the life got from one planet to another, probably in the form of little bacterial-like spores, if indeed this did occur.
What about asteroids and comets? Could they be the spit swappers for larger areas than, say, Mars and Earth?
Well, asteroids and comets, particularly comets, probably came from regions where life didn't have a chance to form. They both contain a lot of organic material. They're very familiar with the organic material from the Martian meteorite, but they probably formed in an environment that was just too cold for life to form, and it's probably because it wasn't on the surface of the planet. It didn't have a thick atmosphere. There probably wasn't a good water where the asteroids and comets formed. And so the likelihood of asteroids and comets having anything that any kind of life at all is quite small. Indeed, most of the meteorites that we know about come from the asteroid belt, and they're chunks of asteroids, and they show absolutely no sign of having life on them.
Okay.
Matter of fact, that's one of the tests that these guys ran when they were looking for Martian meteorites. They took meteorites that are believed to come from the asteroid belt and ran similar tests, and they were all negative.
As a control.
Yeah.
Good. How long ago do you feature this little chunk of Mars was blown from Mars toward us?
It was on the order of millions of years ago. I think that the number that was quoted was something around 13 million years ago. But only a couple of tens of thousands of years ago did it actually hit the Earth. It spent a long period of time floating between the planets.
What then can we speculate with regard to those millions of years ago to conditions on Mars versus what they are today?
Again, this is not my expertise, right?
Understood.
Okay. But it's my understanding that there's been a lot of discussion in the literature that suggested that Mars had a much warmer environment in the distant past. Right? There's clearly signs of running water, that there was running water on Mars, and there's now a lot of evidence in the atmosphere due to the chemical makeup of the atmosphere that lead people to conclude that the atmosphere is much thicker. But that was billions of years ago, not tens of millions of years ago. Probably tens of millions of years ago, the environment on Mars probably wasn't very much different from the environment that you see there today. Mars lost most of its atmosphere because of its low mass, and that didn't take a very long time.
We got back, and my space history year, I guess, is weak, but we did get back samples gathered on Mars, didn't we?
No, we did not.
We did not.
No.
So
the only spacecraft that ever landed on Mars.
That's right. Analyzed and then radioed back. And again, that's the basis for concluding that this meteorite came from Mars, the comparison of that data to what they discovered in this meteorite.
Yes, but let me point out that data indicated that there wasn't life on Mars. Or at least, well, there's some controversy there. But what was really striking about the information that Whiteley found was that there was no organic material on the surface of Mars.
That's what I recall, yes.
And so we were finding organic material in this rock.
If our Mars lander had analyzed this rock, would it have found what our scientists now claim they found in this meteorite?
Well, I mean, there's two answers to that. The first answer to that is it couldn't analyze this rock. It could only analyze dirt. And so that's one of the fundamental issues about what Viking found. First of all, Viking, because it was the first spacecraft ever to land on another planet, they were very careful. And they chose the safest place for it to land, not necessarily the scientifically most interesting place for it to land. So it's like sending what now, technologically, is a very primitive spacecraft. And after all, it landed 10 years ago. Landing a very relatively primitive spacecraft in Antarctica on an ice sheet and trying to figure out what the environment is worth like. So it's not a very good measure, I think, of where of the more interesting places in the river valleys, the below places where we see, sometimes we see fog and sort of indicating that there may be some kind of condensation in the water. And so that's really, really interesting stuff, and so far that hasn't been done.
Why the Antarctic? They're talking now, I read you the story from Reuters here that's clearing this hour, and they're talking about going back to the Antarctic, where they expect or hope to find up to 1,000 more meteorites from Mars. And why the Antarctic? Why not North Dakota or anywhere else?
It's easy to find these guys in Antarctica. After all, it's a rock. I don't see a picture of this thing, but it looks like a rock, right? So you walk out on the field in the middle of South Dakota, and it's going to look like another rock. But what's going on in Antarctica is pieces landed on ice, not embedded in the ice, and the ice is melting, they come to the surface.
Oh, I've got you.
Any rock, you can see a rock there, it's probably a meteor.
Very, very
So
interesting.
that makes it easier to find them.
So it's not that these meteorites particularly attracted to the Antarctica. It's just the quick field of dreams in which to search. All right, Doctor, hold on. We'll be right back to you.
You're listening to Art Bell, Somewhere in Time, on Premier Radio Network. Tonight, an encore presentation of Coast to Coast AM from August 21st, 1996.
We're talking about the Mars story, the Mars meteorite. Are we all Martians? We might be. My guest is Dr. Harold F. Levison, Senior Research Fellow, Department of Space Sciences, for the Southwest Research Institute. We'll ask him a little bit about the Southwest Research Institute in a moment, and get back to it in a moment.
Back to the night of August 21st, 1996, on Art Bell, Somewhere in Time.
Now, back to Dr. Levison. Doctor, are you there?
I am?
Good. All right, let's approach it this way. Somebody just sent me a fax from place called South Lyon, Michigan, and says this rock is much more likely from Earth. Says, come on, Art, a rock from Mars 50 million years ago? Isn't it more likely that it came from Earth? How about Hudson Bay, Guatemala, after an asteroid? This whole topic is not observable, so it is not science, but religious faith. Signed Ron in Michigan. So it sounds to me like perhaps a religious objection, very thinly veiled, but he's saying it is on the part of science and kind of a religious faith. Doctor, how would you respond to that?
Yeah, I don't know what that means. It seems to me that this isotopic dating is very, very consistent to me. I was, for a long time, very skeptical all the asteroids, or all the meteorites that you find would all be from the asteroid. It's rubble pile of rock that exists between Mars and Jupiter.
Right.
But I think that the fingerprinting that they've been able to do on this rock is very good. These isotropic ratios are exactly what you see on Mars. And so I don't see really any scientific conclusion other than it came.
All right.
There's one exception.
Okay.
Okay. The place where it doesn't happen, like normally we see is in carbon. And this was noticed a couple years ago by a group at the University of Arizona. This rock looks like every other Martian meteorite, except for the carbon. And they were sort of scratching their heads about that, but they actually pointed out that the way you can change this carbon fingerprint is by light. And so light can change that ratio.
All right. If
So
we
these ideas that are out there, it's just not never really put forth in a way it's done in the paper, in the science, but there was sort of inkling that date back a couple of years that this rock may be special.
Okay. What is to say that light at a higher form than microbial, all those millions, is it millions of years ago?
Millions of years ago, that the life existed, or that the rock got knocked off of Mars?
That the microbial life existed?
Billions of years.
Billions of years.
Billions.
All right. So then that was during a time when you admitted a little while ago the atmosphere on Mars and the makeup might have been very, very different. What's to say?
That's the correlation.
Okay. What would argue against even a higher life form having evolved from this microbial form?
Depends on what you mean by higher form. If you mean people, I think the evidence is that we just don't see any evidence on the surface of Mars. Who are those? Something like worms, I don't think there is any. One way or another.
If all life on Earth right now were to be extinguished and billions of years would pass, and you were to look at Earth from space, would you know that man had been here?
No, I don't think.
Then why
But
would...
the fundamental difference between the Earth and Mars, what would cover up flying life on Earth, is the tectonic activity.
Yes.
Volcanic eruption.
Yes.
That doesn't exist on Mars.
However, if we look at your earlier model of Mars, what you talked about earlier, there must have been some sort of catastrophic, either short-term or long-term change in the atmosphere and the situation on Mars to make it what it is today.
Yeah, the surface of Mars is a lot earlier than the Earth. And we can date surface sources by counting protons. If you look at the moon, there are two types of terrain. There's the highlands, which have been polarized by meteorites. Craters all over the place, overlapping. That argues that the highlands on the moon is very old. That's how we date back to the formation of the solar system. Like the seas on the darkest, they don't have a lot of craters. That argues that the Earth is relatively young. The Earth has very, very, very few craters. And if you look at Mars, there's quite a few craters, indicating that the surface of Mars actually probably dates back a very long time, probably years. So it's much easier to hide things on the Earth than it will be on Mars.
Do we know anything about how long it might take for microbial life to become early primitive life? I don't know, polywog, something that would fall from the oceans that were once there.
Well, you're asking, I'm certainly not an expert on that.
Right.
That, you have to ask the biologists, really, what happened on Earth. My recollection of college biology is that it took billions of years for single-cell organisms to evolve to multiple cells. very hard to detect. So,
Yet there were some fast steps also in evolution. Was there some steps that to this day really cannot be fully accounted for? The leap between the very simpler life forms, yes, past microbial, to human beings. Nobody still quite understands that particular leap, do they?
well, we understand, again, it's not my expertise, but my understanding is how we understand different parts of it and the whole story of it. But then again, the study of this field is less than a century old, right? So people haven't been thinking of it. And the evidence is buried. And it is under rock, only really like weeds that happens when areas are eroding away and we find new phosphorus. It's very hard problem. I have no doubt that in the centuries or years to come, we will be able to put the pieces together.
So it is possible this meteorite, or one like it, seeded microbial life on Earth that has, over these billions of years, resulted in us.
It's speculation, but I think it's possible. There are a lot of questions if you want to try to believe it. Can a microbe survive an impact that will throw the rock into space? Can it survive millions of years in cold storage, actually, frozen in the sun? Can it survive the impact of the rock back onto the Earth? All these questions need to be answered. So this is very, very speculative, actually. But it's possible.
All right.
Let me just say I don't know anything yet that makes it possible.
Okay. Does the finding of life on Mars make life throughout the solar system, the whole cosmos, much more likely? I mean, here we've got Earth teeming with life, and Mars apparently once had life. And these are but the two planets that we've had a look-see at. So, doesn't that make life ever more likely?
It depends. It depends on whether life formed on Earth and Mars independently. If it forms independently, then I think that's very strong evidence that anywhere life can form as well. And that the universe is probably teeming with life that we can form. Right? But remember, we've been discussing before about the idea that life on Mars and Earth didn't form themselves. And if that's the case, then that the fact that you find life on Mars, if you do, doesn't really tell us anything about how common life is in the universe. So right now, it's a tricky question.
So we're going to have to go to many more places before we can begin to answer that question.
Or study what we see a little bit better. Remember, I asked you when you asked me about this idea of thinking that story. I listened to all these messages that happening before I was calling it about a viable scientific view. All right? And if any one of those questions then that we know that, like could not have survived the impact of through the rocket survive, in transit, then I think we have strong evidence that life evolved on each planet independently.
Are we able, Doctor, to take microbial life in any form into space with a shuttle and or otherwise, and does it survive even limited times in the vacuum and the cold of space?
No, I don't know the answer to that question. I don't know if the experiments are ever done.
Should it be?
I would have to look at the details of what they were planning to do. And I would have to know a lot more about where you find life on Earth and whether it can be stored effectively, let's say deep inside rocks, or so that it would be safe from the harsh environment. Space.
All right.
Space is incredibly hot.
Yeah.
UV radiation.